right, hi everybody, welcome back. We're going to deal with the ionic bonding activity, but we are going to deal with polyatomics today. So, again, we're going to use these examples. Here's sodium and oxygen, but what we're going to do is we're going to flip a couple of these over and turn them, instead of using them as monatomic ions, or those representative ions, we're going to use them as polyatomic. So the chart at the top of the page shows you which ones to flip. So the first one you're going to flip is oxygen, and then you're going to turn oxygen into peroxide. So I'm going to look up the peroxide ion on that common ion list, and I'm going to write down what it is. So peroxide is O2 2-. So now I have a peroxide ion, a polyatomic peroxide ion, and I have 2 sodium ions. Now the oxygen atom, if the oxygen atom existed as a monatomic ion, it would exist just as one little ion with a 2- charge. Peroxide actually exists. It's polyatomic, right? So it's actually 2 oxygen atoms, combined together. Those are supposed to be O's. And then the whole thing has a 2- charge. So this is a polyatomic ion, but it acts as a bundle. When it bonds, these 2 oxygens don't separate from each other. If you want 2 peroxides, you have to double the whole thing and have an additional 2 oxygens. You can't just add 1 because that would split up the polyatomic ion. Polyatomic ions act as bundles. You have to double the entire bundle. That's why if we need to double a peroxide ion, we're going to put it in parentheses and double or triple or quadruple it by putting a subscript at the bottom outside of the parentheses, because we want to triple this entire bundle. Okay, so let's look at this in terms of our puzzles. How will this work? Again, it's asking us to use peroxide and sodium. So we're going to line them up just like we did with our monatomic ions. Our sodium is going to give 1 electron. Now the peroxide ion needs to take 2 electrons. So again, we're going to need a second sodium here. And that will represent 2 sodium ions being bonded and then 1 peroxide ion being bonded. So you can see what the formula looks like here of sodium peroxide, and you can see that it's made out of 3 ions. A sodium, and a peroxide ion bundle. Okay, so hopefully in working with these puzzles and tying them to what the formula looks like, you will start to see that these polyatomics really work as a bundle, and you'll start to recognize what that looks like both on a molecular level from the puzzles and also what that looks like from the perspective of the formula. All right, so take a stab at this side. Make sure you flip the puzzle pieces they tell you to flip and write on the back what the polyatomics are going to be. Put them together, fill out this chart, submit a picture of your puzzle pieces to me, at least a couple examples, and then also submit that chart to me as well. Okay, have fun. Let me know if you have questions.